we have, these are the same base. Okay, quiet guys. So these are the same base. If this is 5 to the this and 5 to the that, then our exponents can equal. So we go 2x plus 3 equals 7, subtract 3, 2x equals 4, divide by 2, x equals 2. And you should know if you had it right or not based off the fact that you can verify every single one of these. Right? B, what can I make them both be? Base what? 7. So 343 is 7 to the what?
3. Base 3.
So then we have x minus 2 equals 3. Add 2. X equals 5. If you're someone who's literally just copying at the speed of light because you didn't do this, I would still go home and do it because it's going to be, there will be questions like this on your test. This is where you practice, right? So if you're just copying me, it's not helpful to you. It is for now, but go back and try them again by covering up the answers. Okay, we can make both these base 3. This is 3 to the 5x minus 1. 81 is 3 to the 4. So I get 3 to the 5x minus 1 equals 3 to the 12x. Then I get 5x minus 1 equals 12x. Subtract 5x. Negative 1 equals 7x. Divide by 7. X equals negative 1/7. D, I can make them all be base 3, right? So this one is going to be 3 to the x. 27 is 3 to the 3. And square root of 3 is 3 to the half. And what do I do when I have two bases, two exponents? Add them. So I'm going to get 3 plus a half, which is 3.5. Or 7 over 2. Same answer, different class. Either of those is equal. Because you have to actually add them. 3 plus a half is 3.5. E, we can make them all be base 3. 27 is 3 cubed to the x minus 2. 81 is 3 to the what? 3 to the 4. But 81 in the denominator is actually 3 to the negative 4. That's it. So it's the same answer, you just raise it to a negative exponent, right? That's all, the only difference if it's in the bottom. So we're going to get 3 to the negative 4, x plus 1, or x plus 3. And then the 1 drops to the bottom, but that doesn't do anything. So we get 3 to the 3x minus 6 equals 3 to the negative 4x minus 12. And so we get 3x minus 6 equals negative 4x minus 12. I'm going to add the 4x over. I get 7x minus 6 equals negative 12. Add my 6. 7x equals negative 6. So x equals negative 6 over 7. B, I tried to give you guys a helpful hint. I said 125 over 216. You have to make it be two bases to the same exponent. 125 and 216, you can make them be 5 and 6. So this would be 5 over 6 to the 3 to the negative x over 4. But do I want 5 over 6? No, I want 6 over 5. So instead of raising it to the 3, what should I have done? Raised it to the negative 3, and then instead of having 5/6, I would have 6/5 to the negative 3. And this is negative 3 over 1. If you're multiplying fractions, I promise you, to make less errors, always make sure that if a number doesn't have a denominator, you write it over 1. If not, you'll try and distribute the 3 to the top and the bottom. If you write it over 1, you will stop yourself from doing that. And then it equals 6 over 5 to the 3x minus 3. So we get 6 over 5 to the 3x over 4 equals 6 over 5 to the 3x minus 3. So we get 3x over 4 equals 3x minus 3. I'm going to multiply by 4. You could have just subtracted the 3x, but I'm going to multiply by 4 to get rid of the problems. So I have to do it to every term. So I'm going to get 3x equals 12x minus 12. Then I subtract my 12x. I get negative 9x equals negative 12. 5 by negative 9. X equals 4/3. And then the last one, I can make them all be base 2. 8 is 2 to the 3. So 1 over 8 is 2 to the negative 3. And what do I have to put 2 to? Nope. 1. So that you make sure you remember to add 1, right? If you don't put it, people will forget to add it and get it wrong. So whenever there's 1 without an exponent, I immediately write it to the 1. So I remember to add 1. So it's going to be 2 to the 4 is 16. 2x plus 1. If you're someone who's like, yeah, I would totally have forgotten that one, I would highlight it. Leave yourself a little thing, because these are your notes, right? I would highlight that 1 and be like, don't forget the 1, because they're the notes for you. Then I get negative 3x plus 9 equals 2 to the 1 times 2 to the 8x plus 16. And I get 2 to the negative 3x plus 9 equals 2 to the 8x plus 17. Do you see how if you forget that 1, most people are going to put to this plus 16? Yeah.
Isn't it just like 2x plus 1 times 4?
Oh, that's a 1. Sorry, I thought it was a 4. That's my bad because I squished it. It is a 1. That's what happens when you messy writing.
So is it 4?
So this is 4. And then it's going to be 8x plus 5. I just thought this was a 4 here, but it's a plus 1. So it's going to be 8x plus 4. We haven't gotten there yet, mister. I always ask questions about the answer 27 steps. 3x plus 9 equals 8x plus 5. Add 3x. 9 equals 11x plus 5. Subtract 5. 4 equals 11x. 5 by 11. X equals 4 over 11. Alrighty. Okay, we're going to flip to the very front of the booklet. I know we were at the very front. We're not going to go right there, but we're going to flip ahead to page 3. So it's the graphs of an exponential. So we're here. So we can have an increasing exponential function or a decreasing exponential. For the most part, what happens is your basic exponential function has an asymptote on the x-axis like this. The x-axis is what equation? What is the equation of the x-axis?
Y equals 0.
Y equals 0. So it actually has a vertical asymptote, which means a dashed line that you can't touch. It's like a pretend electric fence. If you touched it, you just get zapped. So they can't touch it. They get close and close, but they can't touch it. And then it either has an increasing exponential where it increases and goes up for life, but it starts really close to the asymptote, or it has a decreasing exponential where it starts really high And then it gets closer and closer to this asymptote but doesn't touch it. What would cause it to drop below that asymptote? A reflection in the x-axis would pop it below. That's the only thing, right? So if there's no reflection in the x-axis or a negative in front of the equation, it's sitting up here. Okay? Right. We're going to look at some information. So the equation that you use is y equals a b to the x. That's going to be your parent function of an exponential graph. A and b have infinite numbers that they can be. But we're going to look at ones where b is between 0 and 1 and where b is greater than 1. So there are infinitely many possibilities for b and therefore infinitely many exponential graphs. We're going to look at y equals 2 to the x. So if we use the equation y equals 2 to the power of x, how to find our y, we would just plug x in for the exponent, correct? So what's 2 to the power of negative 3? What's 2 to the power of 3? 8. So what's 2 to the power of negative 3? 1 over 8. And then this is going to be 2 to the 2, which is 4, but it's actually 2 to the negative 2, so it's 1 over 4. And then this is 2 to the 1 is 2, but this is 2 to the negative 1, so it's actually 1 over 2. What's anything to the exponent 0? 2 to the 0? 1. Then 2 to the 1? 2. 2 to the 2? 4. 2 to the 3? I don't know why I just wrote 9. Heard you, agreed with you, and wrote the number 9. And then 2 to the 4? 16. So is this an increasing exponential or decreasing? Increasing. It's starting really, really, really small, close to the x-axis, and then going, shoop, as my x's are getting bigger, my y's are getting bigger. Correct? So it's an increasing exponential. Let's just draw it out. So we have 3 and negative 1/8. Well, that's really tight to the line. And then negative 2 1/4. And then negative 1 1/2. And then 0 and 1. And then 1 and 2. And then 2 and 4. And then 3 and 8. And then this is just getting closer and closer to the y-axis, this part. To the x-axis, I meant, sorry. But it's not touching it. So it literally just runs along it. Like the x-axis is an electric fence. Do you see that? Because we can get closer and closer to it, but it can't touch it. And then these run upwards. So this is an increasing exponential. You already know more about exponents than you did yesterday. What's the domain of this bad boy? Yeah.
X has to be greater than negative 3.
Nope. X is the name of the real number system because this baby's going out to negative infinity with your x's, and it's going out to positive infinity with your x's, and my arms are connected by my body, so it keeps going, right? This way forever, and then this way it just goes a little slower this way because I'm steep. But it's still x such that x is the noun of the reals. That's in set notation. In integral notation, that would be negative infinity to positive infinity. So this is set notation because it's the set of. This is integral notation because it's between two intervals. What's my range? Yeah.
Greater than
Why?
equally the vertical asymptote, it has to be greater than.
The horizontal one.
Sorry, yeah, the horizontal.
Yeah, so it's going to be y such that y is greater than 0, y-e-r, and it's because, like what Grayson said, if you look here, we actually have this dashed asymptote, and we can draw it as long as we draw it as a dashed line. Now, on this line is where I said I have the electric fence. At y equals 0, there's an electric fence. So can I equal that? No, I can't even touch that. But the whole graph can be above. When's the whole graph going to be below? We just discussed that. When there's a reflection. So your range will always be greater unless what? There's a reflection in the x, then it's actually less. So your transformations help you from now on, knowing all your transformations. So your range is always going to be greater unless there's a reflection in the x-axis. So an interval notation, that is from 0, round bracket, because it's not equal, to infinity. What kind of asymptote do I have here? Is it a horizontal or vertical? It's this way. What is this? It's horizontal. This is your horizon. This is vertical. Horizontal, vertical. So this is a horizontal asymptote. At y equals 0, because it's the x-axis. What's the only thing that can move your asymptote? Vertical translation. It's the only thing. Vertical stretch, will it make it wider? Can you make something that doesn't exist wider? No. Can I reflect it? No, it's a straight line. The only thing that can move that asymptote is your vertical translation. So actually, your vertical translation is the asymptote. They are equivalent, which we're going to learn about tomorrow. Any intercepts? Any x ones?
0 and 1.
Yeah, 0 and 1, so I have a y-intercept. Do I have any x-intercepts?
No.
Why?
Y equals 0 is an asymptote.
Y equals 0 is the asymptote, which is the electric fence, which means nothing can be on it, which means it can't have any x-intercepts. Now, if this baby shifts, once I have transformations, then I can have x-intercepts. Like if this graph is shifted 1 down, boom, I have x-intercepts. Because that asymptote's going to move to y equals -1. The graph's going to move below, and I'm going to have something crossing the x-axis. Right? Okay. So if b is greater than 1, so our b was greater than 1, we did our a. What's an a? If we have y equals 2 to the x, what was a? A was just 1. I'm going to put it there just so you can see it. A is 1. So b is greater than 1, correct? It's 2. So what happened to my graph? Yeah, it went up. It's an increasing function. So if b is greater than 1, you get the shape above. This is called an increasing exponential function or a growth. Okay. So we are going to look at these babies. So we have y equals 3 to the x. I'm just going to type them in quickly. So we have 3 to the power of x. What's the next one? Is it 4? What does it say on there? I can't see it. 4? Yeah. And then 5.25, right? So mine go blue, red, black, just so you know. As the number's getting bigger, so as b is getting bigger, I have 3, 4, 5, I'm going blue, red, black. Let's see what happens. Okay? As b gets bigger. So blue, red, that is a window to a different question. Blue, red, black. As my b is getting bigger, what's happening?
Closer to the y-intercept.
It's growing what?
Closer to the
Yeah, it's growing, starts with an F, rhymes with aster.
Faster.
Yes, it's growing faster. Because your b is getting bigger, so it actually grows faster. Because if I say 2 to the 2, that's 4. But if I say 3 to the 2, that's 9. Right? Guys, think about it. If I say 4 to the exponent 2, that's 16. If I say 6 to the exponent 2, that's 36. So if I said this, let's think about it. If I say 4 to the exponent 2, that's 16. So the coordinate on that graph would be at 2 and 16, wouldn't it? But if I say 6 to the 2, that's 36. So my coordinate would be at 2 and 36. So 2 and 16 here, 2 and 36 here. Grows way faster, right? It's going to grow way faster. Okay. So what's the value for a for all three of these?
1.
It's 1.
Is a the y-intercept all the time?
Ruining my life every day with you. Yes! It is on a basic a b to the x function. It isn't once you have horizontal and vertical translations because you're shifting it.
No. Yeah.
But on your basic y equals ab to the x, it's your y. Yeah, let's go there. Let's fill a 0 in. See what happens. Okay. So we're going to go y equals, and then there technically is a 1 there, 3 to the 0. And 3 to the 0 is 1. So technically, whenever you fill 0 in for x, your b goes away. It becomes a 1. And what's left? Just your a. So your a is your y-intercept. If and only if there are no transformations, though. Just an a, b to the x function, it's your a. Okay? This one, we would go y equals 1, and then 4 to the 0, which is 1 times 1, which is 1. Okay? And then this one would be 1. It's going to be 1, and then 5.25 to the 0. So it's just 1. My value of b for these are 3, 4, and 5.25. We agree? How did the base affect the function? Yeah. Yes, the growth of the decay rate. So in this case, we only have a growth because it's b is greater than 1. So if b is greater than 1, we have a growth. And as b gets larger, the graph grows faster. So it increases your growth rate, right? Okay, then we'll flip over. What do you think we're going to look at on the next side? We did b greater than 1. What do you think we might do?
B less than 1.
B less than 1 after we do ours. Well, Max ruined this for us, but okay. This is just teaching you that if it's in y equals ab to the x, your a is your y-intercept. So what is the y-intercept of the first function? This one's going to be 0 and 1. What's this one going to be? 0 and 3. What's this one going to be? 0, 4. And this is 0 and 5.25. You guys, it has to be in y equals ab to the x. If we have any horizontal translations, it's shoving it off of there, right? So don't go giving me a translation, all these crazy translations, you're like, it must be the a value. That's not true. That's not real. It's only in the specific case when it's ab to the x. Okay? Your a is your initial value or your y-intercept. Okay, we're going to look at a b. B where it's a third. Now your b value, just so you know, our b values are between 0 and 1 or greater than 1. We do not do negative b values. There's no such thing. Okay? Our base is either between 0 and 1, which makes it decrease, or greater than 1, which makes it increase. So let's see what happens. So, if I go 1/3 to the 3, 1/3 to the negative 3, 27. Because it's going to be 1/3 to the negative 3, which is actually the same as 3 to the 3, right? Because it would flip it. And you can just type these in. This one's going to be 1/3 to the negative 2, which is actually the same as 3 to the 2. Right? Because I can bring this up and it makes this negative become positive. So this is 9. This is 1/3 to the negative 1, which is the same as 3 to the 1, which is 3. This is 1/3 to the 0, which is 1. 1/3 to the 1 is a third. 1/3 to the 2, you have to distribute the 2 in. 1 squared is 1, 3 squared is 9. And then this I get 1/3 cubed, which is 1 out of 27. And then this is 1 out of 81, which that's a really freaking tiny decimal. It's really close. Yeah. Yeah. So negative 3 and 27 is not on here. But negative 2 and 9 is. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have negative 1 and 3. And then I have 0 and 1. 1 and a third. 2 and 1, 9. Like these are just basically just about on the x-axis, but not. Right? Like when we're this tiny, they're basically roaming along it. So we still have our horizontal asymptote at y equals 0. That hasn't changed. But our graph now is decreasing. Did my domain change? No, it was like this. It's now like this. I'm still going out for life, right? My arms are still connected to my body. So XCR, that didn't change. So the increasing or decreasing exponential didn't change my domain. Does it change my range? The whole graph's still above 0. The only thing that affects it is a reflection, right? So that didn't change, the decreasing part. Oh, not equal to. It's an addiction. Or equal to. Did my asymptote change? Nope. Horizontal asymptote. Did my intercepts change? Trick question. Nope. My y-intercept is still 0, 1 because my a value is 1. If my a value changed, it would change. And no x-intercepts. You will never have x-intercepts if you do not have a vertical translation. Because if you do not have a vertical translation, your asymptote is on y equals 0 because your horizontal asymptote of an exponential function is equal to your vertical translation. So if you want to have x-intercepts, or have a chance of having x-intercepts, you need to have a vertical translation to move that asymptote off the x-axis. Right? So if 0 is between if b is greater than 0 or b is less than 1, you get the shape above. This is called a what exponential function?
Decreasing.
A decreasing or a decay function. Want to see something real cool?
I don't know why.
It's so cool. Actually, it's kind of cool. But
Tell me I can put it in my calculator and it'll give me the answer.
no, but you could. Okay. But I want you to see why. Why do we get an increasing with a 3 and a decreasing with a third? Let's see. So 3 to the x, great. We're going to keep it like this. What, you guys, we just discussed this yesterday. What could I rewrite that as? 3 to the negative 1, couldn't I? So I can rewrite this as y equals 3 to the negative 1x, can't I? What transformation's happening? Reflection in the what? In the y, because it's with the x. When it's with the x, it's about the y. When it's with the y, it's about the x, correct? So this one's with the x, so it's a reflection in the y, isn't it? One of them was doing this. 3 to the x does this. 3 to the negative x does this. What axis am I reflecting on here, people? The y. Aren't I? Just because of the rule of a fraction. You can, if you have a fraction, you can write it to a negative 1. The negative's with the x, which means there's a reflection in the y. Okay? So this one, they want the form y equals c to the x. I know my y-intercept is 1, so am I going to have an a value? Yeah, but what would my a value just be? 1. So I'm going to have y equals 1 something to the x. We agree? Now we can only compare by what's going up or what it's going down by, like that b value, if you go from like 1 to 2 to 3 to 4 in the x. If you go like -1 in the x to 7, like how do you compare them, correct? But we are going, this one's going from -2, 16. If I want, I'm going to draw it as a t-table, x, y. It's going -2, 16, -1, 4, 0, 1. These are all going down by 1, correct? Technically up. That's not down, that's up. They're all going up by 1. We agree? So that's how we can compare our y's. When these are going up by 1, what's happening to my y's? Remember, it's an exponential function. It's divided by 4, and we can't write divided by 4 as our b, but we can write 1/4. But we can check it too. If I plug these x values in, I should get these y's. You should walk out with the same thing. 1/4 to the 0, 1. 1/4 to the -1, 4. 1/4 to the -2, 16. Okay? Your homework for this is not super beefy by any means. Yeah, I'm not giving you that.
Oh, no, thank you.
Not gonna lie, I haven't looked at my homework amount of things on there. I don't ever give what they are. That's the maximum amount I have to give. I don't ever do that. Okay, page 342. It's the same page, but you're doing number 1. You guys, I just want to draw your attention to number 4. Number 4 confuses people because it tells you to write an equation of these graphs. Did I just write an equation from a graph? Yeah. I just took the points off of it and ignored there was a graph there. Correct? Same thing here. It goes 0, 1, 1, 3, 2, 9. It gives you points. 3 points. Just like what did I do? I gave you 3 points. It's the exact same thing. It's just on a graph. Don't let it overwhelm you. 1, 3, 4, and 5.
1, 3, 4.
I could have wrote 3 to 5, but I didn't. So you're welcome. I don't know why.